Okay, in this video, I want to look at the summing amplifier again, and I want to use another technique to solve the summing amplifier. And this technique is called superposition. And I think it's a very important uh, tool to have in your bag to actually look at it makes the analysis of some circuits very, very simple. And the basic idea is this, that if you have a linear circuit with more than one input, so just as in this case, we have two inputs, right? We have V1 and we have V2. So one of the things that we can do is we can switch off V2 and look at the output just because of V1. And then what we can do is we can switch off V1 and then look at the output in response to only V2. And then we can add both the outputs, and that would give us the combination of the two. Okay, so here's what I'm saying. Let me just write it again. So step one, find output voltage when V2 is off, which basically means that only V1 is on. And similarly, step 2 would be to find VO when V1 is off, which means that only V2 is on. And then step 3 would be add outputs of step 1 and step 2. To give output when V1 and V2 are applied. Does that make sense? You can only do this for circuits that are linear, and I think as you grow in your understanding of electronics, I think you can make a guess as to which circuits are linear or not, and just take my word for this that this circuit is linear. So let's try to apply the superposition for this circuit. So step 1 is that we switch off V2. Okay, so what we are going to do is we are going to remove V2 from here, and what we are going to do is we are going to make it 0, which means that we are going to connect it to ground. Okay, so if you are going to do that, what is going to be the output here, the voltage here? Now we know that this is the voltage at the non-inverting terminal is 0. So the voltage at the inverting terminal is also going to be 0. So if you look at this R1, on this side of the resistance, there is a 0 volts, and on this side, there is 0 volts. So no current is going to pass through it, right? Because what's the current going to be? 0 minus 0 over R1, which is just 0. So basically, you can ignore this resistance. If you ignore this resistance, this is basically an inverting amplifier, right? So you would get VO. So let me write it, step 1. So for step 1, you get VO equal to minus R2 over R1 V1. Okay, in the next step, what we want to do is we want to put V2 back, and we want to turn V1 off. So what we are going to do is we are going to make V1 equal to 0, that is connect this to ground, and we want to put V2 off. And now in exactly the same way as we did before, there is going to be no current through R1. So basically you can ignore this R1, and then this becomes again an inverting amplifier with an input of V2. So what we get at the output is step 2 is going to be VO equal to minus R2 over R1 V2. And what is step 3? Step 3, what we want to do is we want to find out the output when both V1 and V2 are applied. So we want V1 and V2 both. And how are we going to get it? we're just going to add the voltage that we get at step 1 and the voltage that we got at step 2. So the combined output when both V1 and V2 are applied is going to be minus R2 over R1 V1 plus V2. So it's the same output that we got last time. However, we used superposition to get this. And the idea of superposition, just to kind of summarize, is that you find out the output when only one of the inputs is applied, the other is made 0. And then you find out the output when the next input is applied, but the other input is switched off. And then you add the outputs because of both these inputs to find out the output corresponding to the situation when both the inputs are applied simultaneously.